Alright, this is our review of the factoring that we've been doing with kind of one little small introduction and one little new idea. We're going to be looking at the factoring and adding in the idea of a greatest common factor. So these three examples we see have a greatest common factor in them. And if we look at the first example, we notice that all the coefficients are divisible by 3. So we are going to factor out a 3 first. Remember, factoring out is dividing out, so I'm dividing each term by 3. That gives me x squared minus 8x plus 12. And what that does is it makes this trinomial inside the parentheses easier to factor than what we originally had. So now we're going to look for two numbers that multiply to be 12 but add to be 8, much easier than what it would have been before. Negative 6 and negative 2 multiply to be 12 and add to be negative 8. So this is going to be 3 times x minus 6 times x minus 2. I'm going to go relatively quickly through these, so feel free to pause and rewind as needed. Looking at number 2, we notice that we have 25x squared, which is a perfect square, and 100, which is a perfect square. But the fact is, while it's factorable the way it is, we can also factor out a 25. They're both divisible by 25. So we get x squared minus 4. 100 divided by 25 is 4. And then this factors a lot easier now as a difference of squares, x plus 2 and x minus 2. And there's your factorization. Looking at the third one, as we look at these coefficients, they're all even, so they're divisible by 2. But we also want to check if they're divisible by 4, and in fact they are. 4 doesn't go away, we factor out the 4 and get x squared plus 16x. Sorry, x squared plus 8x plus 16. There are two numbers that multiply to be 16 but add to be 8. There are 4 and 4. And then we'll write that as x plus 4 quantity squared. Again, feel free to pause as you need to and go back and rewind or whatever you need to do. Alright, here we go. Number 1 over here. This is just a greatest common factor. They're both divisible by 2, so we're going to factor out a 2. 2 comes out front. 4 divided by 2 is 2x. 2 divided by 2 is 1. It doesn't go to 0. It becomes 1. If this is a review for you, hopefully it is, you might want to pause and then just come back and check your answers as we go through them. So here both terms have an x. In fact, they both have an x squared. So the idea here is that if I have 4 x's multiplied together on top, 2 multiplied on bottom, we get cancellation, but it's supposed to show that 2 of them are left. So that reduces to x squared. Similarly down here we factor out an x squared. That leaves x squared plus 2. Number 3. We notice they're all divisible by 3. They all have an x and they all have a y. So I'm going to factor out a 3xy. I'm going to divide the coefficients by 3 and take out 1x and 1y. 6 divided by 3 is 2. The y's reduce out. 12 divided by 3 is 4. Both x and y reduces out. 9 divided by 3 is 3. Number 4. There's a 4 and an x and everything, so I'm going to factor out a 4x. 4x cubed divided by 4x, this leaves me x squared. I took out 1x, left 2 x's in there. Plus 2x plus 1. Now we know that this trinomial factors, so numbers that multiply to be 1 but add to be 2 are x plus 1 and x plus 1. Fix that. Perfect. Alright, 5. Everything's divisible by 5 and everything has an a in it, so there's not a whole lot that can be taken out. So divide out of 5a. 5 and divide out 1a leaves you 5a out front, but a squared, negative a squared, b, minus ab, plus 2. And number 6 is a little weird. It does not factor. This is also called prime. So you can abbreviate does not factor, or you can put the word prime, either way. Alright, if you need to go back and look at those, go ahead and do so now. We're going to move on to factoring when a is 1. This is could be considered the easier trinomial factoring. Here we just look at our last number, so I'm going to look at factors of 48 that add and subtract to be 14. So 48 is 1 and 48, 2 and 24, 4 and 12, that gets closer, 6 and 8. Those two add to be 14. So we get x plus 6, x plus 8. That's all we have to do. Here we want to find factors of 5 that add or subtract to be 9. 1 and 5 will not do it. It does not factor, or it's prime. Number 3. We're looking at factors of negative 36 that add or subtract to be negative 5. I'll list them all just to get you used to seeing what all the factors look like, but there are more efficient ways to do this. And we find that 4 minus 9 would give you a negative 5. So this factors 2. The 4 is positive, x plus 4. The 9 is negative, x minus 9. Looking at number 4, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. It's 3 and 4 that add to be 7. That goes straight into our parentheses, x plus 3, and x plus 4. We're still just looking at factors of negative 18 that add to be 3. It's 3 and negative 6. With that x and y, we're just going to put 1x in front and 1y in back. So we get x, y, and xy. Rewrite that. xy. We're going to put plus 3 with one of the y's and minus 6 with the other. And that's our factorization. So if you have two variables in this unit, it's very likely the variables just end up to the first power in the parentheses. Number 6, we're going to look at factors that multiply to be negative 24. Subtract to be 2. So it's positive 2. 6 minus 4 are the two factors that would work. You could list all the factors to 24 if you wanted. So with a 1x squared, we just put that straight into the parentheses, x plus 6 times x minus 4. X plus 6 times x minus 4. Alright, here's a little review of what the difference of squares are. The subtractions didn't want to come through on this, so a squared minus b squared factors to a plus b, a minus b. And there's a little help with the perfect square trinomials as well. Alright, it may help to list your perfect squares. So on your paper you might want to write 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. There are other perfect squares, and we see that in the first example. 121 is 11 times 11. So here we have a perfect square minus a perfect square. Using that rule, we make two sets of parentheses. 1 plus, 1 minus, and the second square root is 11. M plus 11 and M minus 11. Looking at number 2, we have a 1r squared, so we're looking for factors of 49 that add to be 14. If this seemed to be difficult, we might want to see what else we could do, but this one's pretty straightforward, 7 plus 7. Once you realize they're the same, you can check if it's a perfect square, and we have a perfect square trinomial. R squared is a perfect square, 49 is a perfect square, and the middle is 2 times the square roots. 2 times r times 7. And that's our check for a perfect square. Well, let's try to get one more in before the time runs out. 144 is a pretty big number, but p squared is a perfect square, and 144 is in fact 12 times 12. So we want to check if that 24 is 2 times p times 12, and it checks out. So our perfect square trinomial gets factored to the square root of the first, use the sign, square root of the second, or last, quantity squared. Alright, we're about out of time. I'm going to pick this up with the second video.